Okay, so now let's apply it to a two-dimensional projectile motion, right? And we'll use our favorite numbers of 30 meters cliffs, right? So roughly, just to get you an idea, so you actually get physical sense, not just textbook problems. 30 meters, how many stories, how many floors high is that? A door is roughly 2 meters, so each floor roughly is 3 meters, right? It's just a little bit taller than a door. So let's say 3 meters per stories, right? So that's 10 stories or 10 floors high. And you launch something at 5 meters per second, you get a good sense of 5 meters, 1 second. So that's sort of the realistic thing you can throw at. And you shoot at an angle, let's say, of 45 degrees, like this. Okay. And I want to find out the final velocity over here. So let's see if we can do this with the energy approach. If I ask you how long it will take the time, you know that it won't work because there's no t in the equations. But maybe this will work, right? So what's the final speed over here? So I'll ask the final speed when it lands 30 meters below. All right, so now you have to make a couple of decisions, which way is up, which way is down, and also where is your height equals to 0. Okay, so it's up to you, again, whether you pick height equals 0 over here, height equals 0 over here. I'm going to pick height equals 0 over here, and I'll leave it as an exercise for you to try to repeat it with height equals 0 over here, so you know that it doesn't matter. Okay, so height over here is 0. Okay, so what do I know? Over here, let's think about the SUVAT approach. How are you going to do this? First, you need a column of SX, a column of SY. Right, the X direction, Y direction. And then you need to take the 5, you need to resolve it into its horizontal and vertical component. So now you have UX and UY. And then you have AX is 0, AY is -G. If I'm choosing my axis as usual, I like to make it positive up there, but again, it's up to you. SX is unknown, SY is -30. The displacement, right, from here to here. Yeah, and then you need to do both SX and SY, and then ultimately you find Vx and Vy over here, right? So here you have the velocity, and then you need to find, right, the Vy, the Vx, and then if I ask for the speed, you need to recombine those via the Pythagoras theorem. Right, so you use the SUVAT to find Vx, you use SUVAT to find Vy, and then you recombine to find the speed, right? No vector, so speed is that. All right, now that's a lot of steps. You resolve it, xy, recombine it, cosines, sines all starts to pop up. All right, now let's see with our new approach, with our energy approach. Let's clean this up a little bit. Okay, so what do I need? Well, over here, I need the kinetic energy. Let's call it K1. Again, point number 1 here is point 2. Okay, so define your points, and then you go M, okay, mu square. What's the gravitational potential energy? U1. Well, that's 0, so that's mg 30. That's the height. Okay, and over here, what's the kinetic energy? Unknown. Well, I kind of do. It's mv squared, but I don't know what the speed is, right? All right. In fact, that's my aim. All right. U2 is, what's the height? 0. Okay. All right. So now we can go ahead and you can use again matching E1 total equals to E2 total. You can do that. So K1 plus U1 equals K2 plus U2. So and then just plug in everything, do that. I know you can do this. This is in some sense more straightforward, but I want to also train you to think about, because both have its benefits and disadvantages. Looking at its change, so the gain in kinetic energy is the loss in potential energy. Looking at it this way, again, it's a consequence. It's essentially this doing a few steps, right? It means K2 minus K1 is negative of U2 minus U1. You can rearrange that and see, and it's just that. There's benefits of doing it this way, especially when you go to 3B and you look at how heat, the thermal physics, where the gain in heats will create a change in potential energy, or heat gain and heat loss kind of, so it will be easier to think of it this way. So I want to sort of start to train you to think about it this way. So get yourself comfortable with both ways, and then I would suggest, my suggestion is train yourself to be fluent in thinking about it this way. It will help you with 3B, but it's your choice, your life. So, all right, here, right? So the change in kinetic energy is this minus this, right? So 1/2 m v2 squared minus u squared. I am doing two things at one step, which is not a good practice, so let me not do that. So we'll do 1/2 mv squared minus 1/2 mu squared, v2 squared. Yeah, that's good. Minus final minus initial, right? Final is 0 minus initial is mg30. All right, so what is my goal? My goal is to find that. I notice minus minus makes it positive. Also, the m's cancel. Usual. We'll see a couple of examples where the m doesn't cancel. It looks like all the m's cancel because I'm looking at motions like free fall and stuff like that. So the m's, we know the m cancel, but I'll show you a couple of examples they don't as well. Okay, good. So I'm left with 1/2 v squared over here, and I will put that on the other side. So I have g, so positive, right? Positive, so 30g plus 1/2 u squared. Okay. I'll try to, I know I've plugged in some numbers, but I'll try to work with variables as much as I can to, yeah, until the last step. So multiply 2 to both sides. So I have 2 times 30, again, keeping this, I want to show you sort of show you the way to write in an exam to get the most grades as well. So the more clear the steps are, so it's very clear for a grader from here to here to see that what you're doing. It shows that you're multiplying everything by 2, right? So it's a good thing to do this way. All right, now I think we have nothing else to do than to plug in the numbers. So here I have 60g, so g is around 10, right? So 60 times 10 plus here, that's 25, or probably we'll split that in with one more step. Maybe I'll split that actually into two things, right? So here, now it's algebra. You can just do algebra with one step. Algebra don't split into steps, right? That's high school level things. You can, or this is a things that you can do in calculator with one step. You don't need to split into bits and pieces even if you do it in your head, right? So this is 60, 600, 600 plus 25, so 625. Okay. One thing to be careful over here is when you take square roots, make sure you have plus or minus sign, and then convince yourself which one to reject. Okay, so a lot of people forget that and might result in trouble. Probably not this one, but just as a general rule in SUVAT. So V2 is plus or minus square root of 625, and what's square root of 625? That's 25. You can check that with a calculator. So it's plus or minus 25. Now, should I choose positive or negative? Well, we're asking for the speed, right? So the speed should just be positive. So here we reject the negative and put meters per second. If you want, you can justify it, right? Speed is always positive. Okay. And you're done. How many steps does that entail? Well, assume if you do it in SUVAT, you have to write out the SUVAT variables. So that's the same part, the same amount of work here to write out the energies of it. But in terms of equations, you have 1, 2, 3, 4, 5, 6, 7, including me doing some mental math over here. But notice there's no resolving. I did not need to resolve in XY, and magically I got the speed. And I don't need to recombine the XY. So it's a little bit redundant, right? If you think about SUVAT, I split it into components. I did my calculation in the X and in the Y separately, and then I have to recombine it. Here, it's just all together, right? So it's much, much more quicker than the other way around. So so that you really convince yourself that this works, try two things. One, repeat it with SUVAT for this problem, okay, and see if that is do the splitting into angles and all that, and see if you get the same thing. And secondly, try to make the height over here, 0. And the height over here, minus 30. Okay, so we define the absolute u values. Okay, because here, if you take a 0, then your new u1 would be 0, and your u2 would be mg minus 30. Right, so just check that as well. And yeah, you'll see this is a much more quicker way to get this as well. There's obviously pros and cons, right? And I said one of the primary cons on the philosophical side is it's much more abstract to think of energy, whereas forces, you have a direction, it's much more easy. But it does not tell you a couple of things with this simple approach is, if I want to find the time, there's no way to find it. And also it does not, the blessing becomes a curse, right? The fact that I don't have X and Y component is, if I ask you for the X and Y component, or if I ask you for the, the magnitude, I'll ask you the direction of the final velocity, not the speed, the velocity, right? With the direction. You can't find that. So you need the Suvat approach or the kinematics approach. Okay, so pros and cons, but now you know this is one way to do it. And let's look at other ways where it's not so obvious how to do it even with Suvat. So now I've done a couple of examples where you can actually use both, but there are some examples where with Suvat, it's almost impossible to do or very, very complicated to do, and energy is extremely easy to do.